Hi, I'm Sophia.
I'm Alexa.
And I'm Jessica.
And our topic was supercapacitors, which our lab was on this morning. And a big problem nowadays is trying to find a balance between high energy and not having to spend tons of time charging whatever device you're using, like your cell phones or electric cars. And that's what a supercapacitor does. And to understand supercapacitors, it's important to understand batteries and capacitors. And a battery is just a device that you charge that stores a lot of energy, but it takes a long time to charge. And a capacitor is kind of the opposite in a way that it has, it charges super quickly, but it doesn't have it can't store a lot of energy. And so a supercapacitor charges quickly like a capacitor, but it stores a ton of energy similar to a battery, and it actually has a cycle life of 100 times greater than the cycle life of a battery. And we can use supercapacitors in things like cars or buses, where we can use a method of charge or discharge to provide a kind of a greener alternative to using fossil fuels and a lot of waste.
Yeah. So now I'm going to explain the analogy here. So on the left, over here, you see someone that's like eating a platter of fruit, and it takes them an hour to digest it, and then afterwards they can run 20 miles in 3 hours. So this represents a typical battery that you'd see like a AA battery or the battery in your cell phone, where it takes a long time to charge, but once it does get fully charged, it can go for a very long time. And if you go all the way to the right here, you can see that after the person drinks water, it takes their body about 15 minutes to process the water and digest it, but afterwards they can only run for half a mile, and it takes them 5 minutes. So this represents a capacitor, because capacitors, while they charge very quickly in the 15 minutes as opposed to the 1 hour, they also don't hold that much power, so the person can't keep running for as long as the person who ate the fruit. And so in the middle, you can see that this represents a supercapacitor, in that the person drank a fruit energy drink, and it takes them the same amount of time to digest it as it does to for the water. But this time they can run a mile, which is twice as much as they did for if they drink the water, in the same amount of time, 5 minutes. So this represents a supercapacitor, because both supercapacitors and capacitors charge extremely fast, and they have the same amount of charging time. But supercapacitors, since they hold more power, they can keep the person running, or in the literal case, they would keep a device running for longer.
Okay, so another concept that we learned in the lab was how area and distance can both increase the energy that the capacitor can store. So by decreasing the distance between the two plates, a capacitor is formed, and the ions made are able to travel less between the two plates, and this then increases the energy that can be stored. And the energy stored can also be increased when the area of the plates are increased, because there's more room for the electrons. And then one suggestion that we had for this drawing was that they replace the energy drink with more water, because a supercapacitor works the same as a regular capacitor. It just represents how a supercapacitor just stores more energy.
Yeah.
Thank you.
Questions?
Oh, all right. All three at once.
Okay, so what's the main difference material-wise between a capacitor and a supercapacitor?
So supercapacitors, the most effective ones, can utilize nanomaterials. So while like a normal parallel plate capacitor you might see in like a circuit uses like two conductive metal plates, supercapacitors make use of porous nanomaterials. So what happens is that when you have lots of like nanopores in the material, you increase the surface area by a lot, so that increases like the amount of contact that the plates can get with electrons, which means that it can carry like more electrons and therefore have more energy or store more energy.
How did you decrease the distance between your plates?
Like in the analogy?
No, in the experiment.
In the experiment today, we just placed like a thin towel with citric acid on it. So because like there's only like less than a millimeter of space between like the two plates, there's not that much distance for electrons to travel, so they can like travel faster between two plates. And like the citric acid also provides like an electrolyte solution, which makes it easier for electrons to travel from like one end to the other.
All right, I'll do one last question. So you mentioned surface area as being important. What is the difference in terms of magnitude between a regular capacitor surface and supercapacitor in terms of surface area? Do you remember?
I don't remember the exact number for like how many orders of magnitude it is. I think it's several hundred or several thousand.
Yep, that's right. So it's many orders of magnitude, like at least like 2 to 3. So it's quite the difference. So just to give people extra sort of reference. Yeah. So one thing that they learned too. So I'll just add. So about 1 to 2 grams of activated carbon, which is a very high surface area form of carbon, has the surface area of about 2 football fields. For a very, very small amount. So quite the difference between that and obviously a flat plate of the same amount or the same weight. All right, thank you guys. Good job.